Right, my name's Mark Hallen. I'm one of the professors of microbiology here, and I'm going to be giving you 4 lectures on global health and emerging infections. They're going to be, unfortunately, back-to-back, 2 today and 2 a week's time. I'm obviously not going to just speak for 2 hours. There'll be a little comfort break between the first and the second lecture. There was also a problem with communication with the office. They've only made a handout for the first lecture. So I'm sorry, but you'll get a handout for the second lecture along with lectures 3 and 4 next week. But you will get handouts for all of it. There's a PDF available on WebCT for each lecture as well. There's some further reading, and I'm recording the lecture, and I'll make it available on YouTube as a slide cast so you can follow it later in your revision or whenever. Okay, so I'm going to start by looking at the global burden of infection and why should we be interested in this at all, and then look at one old foe, malaria, in this first lecture. So that just lays out the series of lectures that we have here. Global burden of infection, malaria, then looking at TB, a little bit on leprosy, but mostly on TB. Then looking at what we might call emerging infections, new foes that have come into our consciousness over the last decade or so. Some of them, in fact, even the last year or so. Look at disease eradication. And then finally, I normally give a lecture on lab diagnosis of infectious disease, but Charles Penn is going to give that this year because there's a diary clash and I just can't do it. I've set up a Facebook module, Facebook page for the module. I haven't actually posted anything on it this year, but if I see interesting things, papers coming out that are pertinent to the course, I put them there so you can identify further reading that's right up to date just before your exam, if need be, by going to that Facebook page. I also am active on Twitter, so if any of you are on Twitter, you might like to follow me, and if I see a paper on malaria or TB or something, I sometimes tweet that. Okay, so looking at infection, the global challenge. Now, in developed countries like here, we have infectious diseases causing rather fewer deaths than non-infectious disease. We're now worried about dying of a stroke in old age, or heart attack, or cancer. But if we look across the whole world, infection is by no means a spent force. I mean, more than 15% of all deaths are a result of infectious disease. And even in developed countries, it's not all over. Infection is still a threat. You may have seen in the news about West Nile fever and the worries about that in North America. SARS blew up, and we'll talk about that in the lecture on emerging diseases. Last summer, Germany was decimated by this outbreak of a sugar toxin producing E. coli. That's one of the most advanced countries in the world. So it's clear that infection is still an issue. And effective control of infectious diseases remains a challenge. And this is leaving aside all the troubles we have in hospitals and with hospital infection. This is just showing you from the WHO website the major killers or causes of death around the world. And you can see that in the world now, ischemic heart disease, cerebrovascular disease, number 1 and 2, but lower respiratory infections, number 3 there, diarrheal disease, number 5, HIV/AIDS, number 6, tuberculosis, number 7. So it's clear that across the whole world, infection is still an issue. And if you look at low-income countries there, respiratory tract infections, diarrheal diseases, HIV/AIDS, still up there as big causes of death. And tuberculosis and malaria, the 2 things we're talking about today, are in at number 7 and number 9 in terms of causes of death. And if you look at child deaths, and you look at what's causing those around the world, you see that there is a big skew here. If we look at in Africa, we see that diarrheal diseases and malaria and HIV/AIDS are still very big problems there. And so in sub-Saharan Africa, infectious disease is still a major player in terms of human mortality, and particularly in terms of childhood mortality. And this looks at adults. And if you look at the adults there, you can see again communicable diseases, and particularly in adults, HIV/AIDS as a very prominent cause of death among adults. So that's just to set the scene and point out how important infection is. I'm now going to spend the rest of the lecture concentrating on one particular infection, and that's malaria. Now, this is actually a very complex infectious disease. It's got a very complex life cycle. It's deadly, can kill. It's caused by a eukaryotic parasite, not a bacterium, but a parasite. It falls in a group known as the apicomplexans, and malaria is caused by members of that group that fall within the genus Plasmodium. Now, the most serious forms of malaria are caused by Plasmodium falciparum, but there are 3 other causes of disease in humans. In fact, there are some others as well. Plasmodium noseli is also recognised as a cause of human malaria nowadays. But it's falciparum that is the major killer. And they're naturally transmitted by the bite of a mosquito, one particular kind of mosquito, the Anopheles mosquito, and it's only the females of that particular mosquito that transmit malaria. It is a leading cause, as we saw in those league tables, of morbidity. It means people being sick, and mortality, people dying across the world. It's a major threat to pregnant women and to children. And it's estimated that over 40% of the world population, that's 3.3 billion people at risk in 109 countries. 250 million cases worldwide in 2008, and something like 1 million deaths in children every year. About 80% of those in tropical Africa, 800,000 deaths every year. And as we keep saying, the economic burden is highest in Africa, $12 billion or more per year in direct losses in terms of illness, of treatment, premature death. But if you look at the wider picture in terms of the kind of brakes on economic growth that comes from malaria, it's even worse than that. Of course, malaria sometimes hits the headlines in this country. A couple of years ago, we almost lost Cheryl Cole to malaria. She went on a holiday to East Africa. She came back with falciparum malaria, and without effective treatment, she would have died. These are some quotes here. She thought she had a hangover, but it got worse and worse, feeling flushes, goosebumps, blue lips, blue fingertips, blue toes, and boiling hot. Couldn't breathe properly. Liver function was off, kidney function was off. No oxygen levels went down. She had 24 hours to get fluid out of the body, otherwise her insides were going to pack in. And she actually asked the nurse whether she was going to die, and the nurse said, well, that is a possibility. Rather frank statement to be making. But anyway, she did turn the corner and survived. In fact, I put a video of her describing her symptomatology actually on the web CT. Now, this is a rather scary figure from Wikipedia, so it's open access. This shows you the complex life cycle of this parasite. You have the parasite cycling through humans here, having these various stages in the blood of humans, and then, sorry, here's the human one, and then over here you have it in the mosquito as well. So let's start off with the mosquito. So as we mentioned before, the primary host and the transmission vector is the female Anopheles mosquito. These young mosquitoes bite humans and they ingest what we call the gametocytes, one particular form of the parasite, in a blood meal. And then they differentiate into gametes and they fuse into what's called an ookinete. That penetrates the gut lining to produce what's known as an oocyst in the gut wall, and then that ruptures and releases these sporozoites, which then migrate to the salivary glands. And it's those sporozoites which are injected into the human bloodstream with saliva when the mosquito feeds. So there's this complex life cycle within the mosquito. When it gets into humans, we have these various blood stages here. So you get sporozoites travelling through the blood very briefly, only for an hour or around that time, into the liver, where they then differentiate into merozoites and then go into this life cycle within the blood, asexual life cycle within the blood, and then some of those will differentiate into the gametocytes, which then go off back into the mosquito. And various things are happening here. You've got merozoites invading red cells, so they parasitise the red cells and live inside the red cells. Inside the placenta, this then causes adhesion to the blood vessels and sludging up the blood and infarction, clotting off of the blood and destruction of tissue there. Same thing happens elsewhere in say, the brain, causing these problems. So again, looking in more detail, so in this so-called exoerythrocytic phase, outside of the red blood cells, the sporozoites go into the bloodstream. 30 minutes, actually, I was mistaken, it's not an hour, it's 30 minutes, they get into the liver, and then they multiply asexually, asymptomatically. You don't know that you've been infected for 6 to 15 days, and then each one of them differentiates into thousands of the merozoites, and they rupture the liver cells, the hepatocytes, and escape into the blood. And the merozoites infect the red blood cells, and they go through multiple rounds of asexual reproduction, where they have these different forms, ring forms, the trophozoites, schizonts, and the merozoites. And what happens as they're differentiating like this, they rupture the red cells at this stage here, and then they reinfect a load more red cells. And this tends to come in phases, and so you get this cyclical fever as they're all differentiating in phase, and then they will rupture the red cells and release the destruction of the red cells and release of cytokines and so on triggers the fever. Now, just some of those merozoites then go on to differentiate into the sexual forms, into the male and female gametocytes. There are some species-specific features. So most of what I told you there was common to all the different kinds of malaria that we have. In Vivax and Ovale, you have these so-called hypnozoites, where they go into the liver and they stay there instead of just using the liver as a jumping off point to get into the blood. They actually can live in the liver for months or years and then reactivate and produce the bloodstream forms. And so in these cases, someone might get infected in India and then come to the UK, and 5 or 10 years later, suddenly their malaria springs up. Luckily, we don't see that with Plasmodium falciparum. But as I say, falciparum makes the erythrocytes stick to the walls of small vessels. This leads to hemorrhage, infarction in the placental and in the placenta and in cerebral malaria. And so this can threaten a pregnancy in a pregnant woman. If it gets into the brain, it can then cause brain damage and death, cerebral edema, and be a cause of death. So that, in a nutshell, is the life cycle of the malarial parasites. What about their history? Well, it looks as if they co-evolved with anthropoid lineages in Africa with great apes and humans. There are some controversies as to where did humans get malaria from. It's clear that malaria going around the world, particularly falciparum malaria, seems to have been carried as part of the migration out of Africa. So Africa was where it all started, and then it moved around the rest of the world, for falciparum malaria at least. If you look in the literature, you can get descriptions of these periodic fevers, where you get fever every 3rd day or 4th day or whatever. Way back in China, 4,000 years ago, in the 2nd century, they actually described the use of a plant as a remedy, and that plant actually in the 20th century, late 20th century, was kind of rediscovered and taken seriously as a treatment for malaria, and is now a major weapon. Chemicals coming from that plant, a major weapon against malaria. Hippocrates also noted similar things. So New World explorers, missionary slaves took malaria. But one thing that was brought back from the New World was that the Jesuits actually brought back this Peruvian cinchona bark, which is the source of quinine, which is another one of the great weapons in the armoury against malaria. The name malaria just means bad air in Italian, and the idea was that this illness was associated with miasmas coming out of marshy land. So people were kind of aware that you're more likely to get this close to marshy land, but they thought it was something floating in the air. They didn't make that connection with the mosquitoes breeding there and then biting people. Just to show you that this is a rather hot topic in terms of the origins of Plasmodium falciparum, there have been a number of papers over the last few years, and they all say different things. So this paper here actually claimed that they had good evidence that malaria parasites came from African apes, and particularly bonobos, the pygmy chimpanzee. That's what they said. But then there's another paper that came out a short while later that said, actually, no, it comes from gorillas, and gorillas are the source of Plasmodium falciparum in humans. And I think this is probably where the consensus is now sitting, is that gorillas probably are the cause. But, these things are very fast moving, lots of work going on analysing all these field samples. It's possible that someone might come back with a different answer in a few years. In terms of history, the parasites were first seen in the blood in the 1880s by this guy Alphonse Laveran, and he got the 1907 Nobel Prize for that. He suspected, but didn't ever prove, that the mosquito was a vector. So another guy, Patrick Manson, at the same time, another tropical disease specialist. But it fell to one guy, this guy here, Ronald Ross, to actually work it all out. So in 1897, while he was working within the health service of the British Raj, within the army of the Raj in India, he was looking at some Plasmodium falciparum that had been fed on a malaria patient, and he saw these oocysts there. And then he went on to confirm that malaria did cycle through the mosquitoes. If he didn't do it with humans, he actually showed a form of malaria you find in birds actually did transmit through that particular route. There's Ronald Ross, a typical Victorian, with his wife and his various servants there. He got awarded a Nobel Prize in 1902 for this discovery. I think it was one of the first Nobel Prizes, in fact, in medicine. He was an odd guy. He kept these notebooks, rich notebooks. He also composed poetry in his spare time, and I think the consensus is most of his poetry was doggerel, which is rubbish. But this gives you a feel for the kind of way he felt about his discovery when he discovered this. He said, "I know this little thing a myriad men will save. O death, where is thy sting? Thy grave, thy victory, O grave. I find thy cunning seeds, O million murdering death." Rather overblown, you might argue. On the other hand, you might argue, well, this actually was a decisive time in history where we understood this major killer for the first time. Now, of course, there are always multiple interpretations of history, and the Italians will tell you, well, it was some Italians actually discovered how malaria worked out. There were these three Italians here, Grassi, Bignami and Bastianelli, who described the developmental stages of human malaria parasites in mosquitoes. It was human malarial parasites that they actually identified, and they took mosquitoes from a patient fed in Rome, and these were sent to London and fed on volunteers. Whether you'd be allowed to do those kind of experiments now, I'm not so sure. Perhaps you might still be able to. But anyway, those two volunteers both developed malaria. So the Italians will claim that they sorted malaria, and that Ronald Ross he just mucked about with a few birds, and that wasn't significant. Obviously, great ideas sometimes are in the air and they come at the same time. And all of them deserve credit, really. Guy working in Demeion in South Africa showed that malaria could be controlled by frequent spraying of walls with insecticides known as pyrethrins back in the 1930s. And in 1934, we had the first synthetic drug, chloroquine, and it wasn't developed for that purpose, but it turned out it was, just by chance, a very good and safe, effective anti-malarial established by the 1940s. In the late 30s, DDT was discovered by this guy Paul Muller in Switzerland, and he won a Nobel Prize. A lot of Nobel Prizes coming out of work on malaria, but perhaps that's just because it is such an important disease. A couple of guys working in England showed that there is this liver stage, and an American clinician then showed that actually there was this dormant phase in the liver for some of them, for Vivax in particular. Okay, that's a bit of history. What about trying to control this infection? Well, in 1900, over 3/4 of the world population lived within the shadow of malaria, 140 countries. Obviously, the world population then was much smaller than it is now, so that was 1.6 billion people, but still a very large number. And 3.1 million deaths, and most of those deaths were outside of sub-Saharan Africa back then. The US launched a national malaria eradication campaign in the late 40s and early 50s, and they actually managed to eradicate malaria from the USA. They sprayed millions of houses. They went from 15,000 cases a year in 1947 down to 2,000 cases in 1950. Similar successes were seen elsewhere. In Sardinia, they were seeing 75,000 cases. A few years later, they managed to wrestle that down to 9 cases per year. And so, buoyed up with these test cases, there was an effort to eradicate malaria from the surface of the globe. This global malaria eradication campaign that ran from the 50s into the 70s. It was spearheaded by a guy, Fred Soper, an American epidemiologist who worked at the WHO and involved more than 50 countries around the world. They used lots of DDT to spray houses. They went case finding, treatment, preparation, attack, consolidation and maintenance. It was run like a military campaign in a sense. And it basically got malaria down to 50% or so of what it had been before. And it worked pretty well in countries with temperate climates and seasonal transmission of malaria, where only at certain times of the year would you actually get transmission, because you had that seasonality. In Sri Lanka, they went from more than 2 million cases down to just 17, almost eradicated it completely. But the problem was that it was, it's like the boy with his finger in the dike, the hole in the dike here. As soon as you stopped any of these interventions, things bounced back. And that's what happened in Sri Lanka. Once they stopped doing this intensive work, it bounced back to 500,000 cases a year. And in some places, they really didn't get very far. So places like Indonesia, Afghanistan, Haiti, Nicaragua, no progress really at all, even though they were trying to make progress there. And they basically ignored sub-Saharan Africa. That was too difficult a problem, perhaps, and they didn't bother to even attack the problem there. And so, by the 70s, it was clear that this eradication campaign had failed, was not working. There were a number of factors that led to it not working. Some of it is kind of Darwin in the drugstore type stuff, that the mosquitoes began to develop resistance to DDT through a process of natural selection, and the parasites became resistant to some of the drugs through a similar process. The world was, not a good place for this. There were wars and population movements going on that obviously interrupted any attempts to actually try and control disease. It was a very top-down thing, so the actual the lack of community participation in the countries that were being targeted. The money was coming down from the rich countries, but they weren't always sustaining that. They were sometimes turning off the tap. And so it was 1967, in fact, that the World Health Assembly, which was the kind of executive wing of the World Health Organization, decided to abandon eradication, and they would focus instead on trying to control things. And this E word, eradication, almost became an unmentionable word that you weren't allowed to use in kind of civilized circles in the WHO, in public health and epidemiology. So they kind of wrestled things down to about 40% of the world population at risk. So, okay, the cup was, 60% full. You got rid of it from 60% of the population, but still 40% at risk. Things went quiet for a couple of decades, really. Molecular biology started trying to come up with new vaccines and so forth. But in terms of major initiatives, we had to wait until really the turn of the millennium. And the WHO's Director General launched this new initiative, Rollback Malaria, in 1998. And then there was this Rollback Malaria Change Initiative a few years later. So scale up, sustain control, use this word elimination rather than eradication. And in 2007, Bill Gates actually gave a talk where he used the term eradication again. Now, you can argue about what kind of man Bill Gates is. He produced a rather mediocre operating system that made a lot of money out of it. He may have a kind of Asperger's spectrum kind of personality, but that means he sees things in black and white and doesn't see all those subtleties of grey. And sometimes that can be a good thing. His view was, a kind of West Coast American view, why don't we just get rid of this problem and eradicate it from the world? What's the problem? There's nothing's impossible, let's just do it. And he really did stir things up. So then there was this Global Malaria Action Plan in 2008, idea of universal coverage for all populations at risk with locally appropriate intervention. So the idea is that you can't have someone in Geneva at the WHO headquarters saying, this is what we're going to do, and just issuing an order. You have to get in with the local populations. And what they wanted to do was reduce things by 50% by 2010 and 75% by 2015. And reduce deaths by similar kind of levels to 50% in 2010, and then 0 preventable deaths by 2015. And they wanted to eliminate malaria in 8 to 10 countries by 2015. And afterwards, all the countries that might be considered in the pre-elimination phase. So, this basically gathered a snowball effect here. You've got this global fund set up to fight AIDS, tuberculosis and malaria, with billions of dollars committed to the global fund. Huge scaling up in terms of interventions and funding. And you can see here malaria elimination, malaria eradication. After Gates started using the E word for the first time, the rest of the world suddenly latched onto that, and people started talking about this again as a real possibility. So how do we control malaria? Well, we have effective medicines, and we have relatively inexpensive preventative measures available. But unfortunately, these reach only a small proportion of those in need, and that's mainly because this is a disease of poverty. It occurs in countries where people cannot afford, and healthcare services cannot afford, to put these simple, effective measures in place. In the last decade, we've also seen new medicines and new approaches developed in terms of case management, vector control, epidemic detection and control. We still have this challenge of producing a widely available vaccine that provides a high level of protection for a sustained period, and we've not quite met that. We're getting a lot closer in the last couple of years than ever before, but we're still not quite there with that. So let's have a look. Where would we intervene? Where are the Achilles heels, if you like, or the choke points of malaria? Well, you can look at three things. You can look at the parasite, the host, or the vector. And we can focus on each of those as places where we can start to make interventions. And I'll go through each of those in a bit more detail now. So, vector control. We want to protect individuals against mosquito bites from infected mosquitoes. And we want to reduce the intensity of local malaria transmission as well. So how do you do that? Well, it's two things: nets and sprays. So sleep under a malaria prevent malaria by sleeping under a mosquito net. And that protects you at night when most of the bites are. In fact, you can combine the physical barrier of the net with the chemical barrier of insecticides. And there's a certain jargon, I don't quite know where it comes from in the control of malaria. I don't know if it's from the WHO, but they love these little acronyms. So you've got ITN for insecticide-treated nets, and then long-lasting insecticidal nets are called LLINs or LINs. These have this potent insecticide in them which maintains its efficacy for over 3 years. So they have the physical barrier but also killing the mosquitoes. And in Africa alone, 140 million nets were distributed between 2006 and 2008. So a massive effort going on. And in fact, a couple of years ago, before Cheryl Cole actually got sick, there was her and a number of other celebrities were climbing Mount Kilimanjaro to actually get funds for this kind of effort. And that's when you start to think, well, maybe humanity can actually get these problems sorted out. If they can get celebrities like that to understand the issue and the problem and work with it, then there is hope for the future. There's another technique known as indoor residual spraying, or IRS as it's called in the jargon. You spray the walls inside the house. Now DDT was initially used for this. In this picture here, I think this comes from Sardinia, I think, in the 1940s. Go into the house and spray the walls. DDT fell out of fashion because it had also been used much more widely in the environment. And there were concerns there. This book, Silent Spring, about all the birds are going to die off because all the insects were dying off and all this, and the shells, birds were getting thinner and so forth. So there was really a backlash against DDT, and it's actually been banned very widely. But there's a lot of debate now about whether it should be allowed to be used for this very restricted use inside houses, inside dwellings. So it's not getting out into the wider environment and polluting everything. It's very much, because it really is an effective weapon of mass survival, as some of the people trying to proselytise this approach call it. If you know precisely where the mosquitoes are actually breeding, and there are relatively small sites, you can actually go in and then apply larvicides to that, or you can drain the water sources as well. But obviously that is only an issue if you've got a very constrained target there. If they're breeding all over the place and there's no way you could drain the rivers and the marshes, then you can't do that. Now, there are some interesting alternative approaches to vector control that are being mooted at the moment, haven't actually been adopted for malaria. One is the so-called sterile insect technique, and this is a method of a so-called biological control, which you can argue is much nicer than chemical control because this is much more targeted. So what you do here is you radiation sterilise insects, and then you release them, and they compete with the wild males for female insects. And so they are mating away with all those females, but they're sterile, so that all that activity, all that action out there is not going to lead to any more mosquitoes. Now that approach has actually been used in North America to eradicate a particular fly, known as the screwworm fly, an agricultural pest. And so there's a lot of discussion about could the same thing be done for mosquitoes in Africa. An alternative approach is to actually make transgenic parasite-resistant mosquitoes. So we say, well, mosquitoes are just a fact of life. They're a nuisance when they bite you. They're not infected with malaria, though it is only a nuisance. So let's not get rid of the mosquitoes and disrupt ecology quite so dramatically. Let's just get those mosquitoes to be resistant. And there's some evidence that you can make parasite-resistant mosquitoes that will not be able to transmit malaria. Okay, you can now then focus on the patient, the host, the human, and look at case management. And one of the key points is how do you diagnose malaria? Because malaria doesn't really have any, apart from the periodicity of the fever, which is not a reliable sign, it's just a febrile illness. You just get a bit fluey, you feel, you might feel your bones are aching, your muscles are aching, you've got a bit of a headache, you've got a temperature, you want to go to bed. But then that would also be the case if you had influenza or you had Lassa fever or you had any other one of umpteen different things. So actually making an effective diagnosis is considered a good thing to do. And you can do this in two ways. You can do it by microscopy, and you could argue that microscopy, well, that's a nice low-tech approach because all you need is a microscope and some stains. It is. I mean, you can make these get these kind of images down the microscope. This one's very easy to interpret, but sometimes it can be very difficult to actually see the malarial parasites. You have to make what they call thick films. This is a thin film, which is easy to interpret, but a thick film is much harder thing to actually get to grips with. So you really need to have well-trained, competent microscopists. This is something where it would work in a kind of hospital or clinic environment, but you wouldn't be able to go into a village very easily and train people in the village to maintain this or anything like that. So there's been a lot of interest in so-called rapid diagnostic tests, the kind of effectively pregnancy test for malaria. So similar to what you would do if you were having a pregnancy test, you have a strip impregnated with monoclonal antibodies, and you get a coloured line or various coloured lines to tell you whether negative. You get one coloured line just to show you the test is actually still viable and working, and you get different coloured lines depending on. This is obviously much easier to use and doesn't require any electricity, any training or anything like that, but it is an order of magnitude at least more expensive than doing traditional approaches with staining. And so there's some lively debate in the field as to how much these kind of tests should be rolled out and how much you should rely on conventional approaches. Another issue in case management is targeting pregnant women. And so again, I don't know why they have these funny acronyms, but they call this IPTP, intermittent preventative treatment for pregnant women. And the idea is that you're preventing a malaria transmission, malaria infection, I should say, in high transmission settings. So you're saving the pregnancy, keeping the woman safe from infection. And in these high transmission settings, it's considered a sensible move to give doses, even whether you don't have to make a diagnosis or do any tests, you just give this prophylaxis to all pregnant women as a way of blanketing the problem. In terms of treatment, obviously when you're managing a case, you want to get the treatment working as effectively and as quickly as possible so that you can cure that individual, you can prevent them from getting the severe, potentially fatal disease, you can prevent other negative sequelae, so they will get malaria-induced anemia if you leave it untreated. The fetus the pregnancy may be lost, or the fetus may suffer as a result of poor oxygenation in parts of the placenta and come out much less healthy than it would have done otherwise. But of course, if you treat quickly and effectively, you may also curtail the transmission of malaria. So in terms of the community as a whole, it's a good idea to get those cases and treat them as quickly as you can to reduce the whole parasite burden in that community. So that drug I mentioned earlier, artemisinin, coming from this plant from China, that in combination with other therapies are now, as the so-called artemisinin combination therapies, are now used as the first-line treatment against falciparum malaria. So a whole interesting story about how that plant was discovered in China, used in China. Then there were issues about generalising that to the rest of the world and all sorts of political issues. But now we're at the stage where we recognise that Chinese medicine actually delivered this very useful therapy. Chloroquine and primaquine are used against Vivax, they're still effective there. And we do use prophylaxis to prevent malaria in travellers to malaria endemic countries. Whether Cheryl Cole took prophylaxis, I don't know. Perhaps not. It's not always 100% effective. We do get, every year you get in this country, cases of falciparum malaria from people returning from abroad. This isn't going to affect the global problem of malaria. Nobody's suggesting you could do this on a community-wide basis in endemic areas. But if you have travellers going to those in malaria endemic areas from where there is no malaria, then this is considered a sensible thing to do. There are some problems we saw very early in the kind of chemotherapy malaria that you've got chloroquine resistance. Now we're starting to see some evidence of resistance to these artemisinin as well. One of the issues here, as people have kind of learnt from the past, is that actually it's a bad thing to use one of these agents on its own. If you use agents in combination, then the chances of resistance arising are much lower. So if you think about it, I don't know what the figures are, but let's say that 1 in a billion parasites, just by chance in any population, happens to be resistant to a particular drug. 10 to the 9, 1 in 10 to the 9, and maybe the average patient has got 10 to the 12 organisms on board. You know, there's 1,000 of those that will grow up and form a new population when you treat. But if you give 2 agents, where it's 10 to the 9, 1 in 10 to the 9, and 1 in 10 to the 9, it's 1 in 10 to the 18 that you'll have resistance to both of those by chance, which means that that won't exist in that population. So that's the kind of thinking now, that monotherapy is a bad thing in this kind of situation. It should always be using combination therapy. Actually checking that the patients are getting better is important. I actually had some slightly cross words with a trainee in medical microbiology a few years ago, because she just said, "I'll treat the patient with quinine," and that was it. And I said, "No, you must remember to call the patient back and do serial blood films to actually check that the patient's parasitemia is actually coming down, and not just assume that everything's all right just because you've given the treatment." And in fact, you can do genotyping now to determine whether someone has just got, whether they've relapsed, you didn't actually treat their malaria properly, or whether they got reinfected, whether it's a different strain or the same strain. Now, there's a lot of interest in getting new drugs against malaria, and again, there is a lot of guarded optimism here. I think 5 or 10 years ago, people would just throw their hands up and say, "Oh, we're losing our only frontline agents, and it's all going to go wrong, and it's all going to resurge again," and going back to where we were 20 years ago. But there are these major international ventures of medicines for malaria venture. There are a number of drugs that have at all stages in the pipeline: preclinical, phase 1, phase 2, phase 3, and a couple that have actually been approved there. And there is a review in Nature, which I put the link up there if you're interested. Okay, what about a vaccine against malaria? Well, the problem with the blood stage of malaria is it's just there are masses of them, huge biomass of parasites in the blood at any one time. And to try and actually target all of those and wipe them all out with an immune response is very, very difficult. We know that these parasites actually are very wily. They have this antigenic diversity. They were continually changing their surface antigens. And so the immune system doesn't have a fixed target to lock onto. So that creates a big problem. They have their own mechanisms for evading host responses. And so those are reasons for saying, well, it's going to be too difficult. The only reason for saying, actually, it might still be possible is that if you live in an endemic area and you get repeated infection, you do actually develop some kind of immunity. So you get a control of your blood stage parasitemia, and you get some kind of effective immunity. Now, that's obviously not a good thing, because through childhood, some of those children will actually die from overwhelming malaria. Some of them will survive, and it's not. But the fact that some do survive and they go on to have parasitemias that really relatively light in terms of their severity and clinical outcomes suggests that there may be something here. In fact, this is an issue. If you have one of the recurrent problems you get is that people who their families come from an endemic area They then come and settle in the UK, and the children grow up here and they have no exposure to malaria at all. And then they go back and visit relatives in their home country, then get exposed to malaria, and then they can be seriously ill. And the parents may be okay because they, as in childhood, got some immunity, but the children who've had no exposure. So that's a common scenario that you see when you get malaria returning to the UK. Okay, what about the pre-erythrocytic parasite stages? So those sporozoites, so the malarial parasite bites you, and you've got that half-hour window, you've got those sporozoites tracking their way through the blood. And there is some success here with whole-cell irradiated and genetically attenuated parasites. And there is a subunit vaccine where you're using sporozoa antigens as RTSS vaccine in phase 3 trials that shows some promise here. I think I've got a slide showing the latest results of that in a moment. So this did actually appear to have efficacy in a trial. The first malarial vaccine that really did have a useful kind of efficacy. It wasn't 100%, it was 50% protection, but that's still better than nothing. Another idea is the idea of a transmission blocking vaccine. So could you give a vaccine that would actually block those gametocytes, so the things that the mosquito is going to suck up in the blood? Well, if you could wipe that out, you wouldn't actually control the infection in that individual, but you'd stop that individual being infectious for other people. And there's a lot of debate about, well, is this a good thing to do? It's a kind of altruistic thing to do. You're preventing transmission in the community, but you're not doing anything for that individual that you're vaccinating. And so, again, that's very interesting, very lively discussions in the literature about that. Oh, here, I did remember, I did have this slide. So this is from 2011. It's a very exciting paper in the New England Journal of Medicine. First results of phase 3 trial of this RTS-AS01 malaria vaccine in African children. And they showed here that they've got about a 50% protection. Now, it's not yet a slam dunk. This is not definitely going to go across the world and be used immediately. This needs to be rolled out further and people need to move forward cautiously. But this is a sign of hope in the field that there is actually a vaccine that does seem to have some kind of efficacy. So the last 5 minutes, what about where are we at with all this? Are we actually winning the battle or the war against malaria? This is from a recent review. I think it was in Science magazine. So is the cup half full or the cup half empty? In some parts of Africa, we've seen a decrease in cases of greater than 50%. Botswana, Eritrea, Namibia, Rwanda, some of the islands there, Cape Verde Islands, Sao Tome and Principe. In South Africa, Swaziland, Zambia, not anywhere. We've got 25%, but we've got a whole load of places where we're not actually winning still. So it's clear that, the idea that you should write off sub-Saharan Africa, as people used to do, as a hopeless case is misguided, because some parts of sub-Saharan Africa are winning, but there are many places that are not. The rest of the world, again, you can see tremendous success in the Americas there, parts of Southeast Asia, in the European region, and so forth. But here also in limited evidence of decrease in some of those countries there, Brazil particularly worrying because it's such a large population, such a large country. This is just a focus from this Science magazine article in 2010 looking at the fact you can't generalise across Africa. You've got to look at each country and each region separately and make an assessment. And so they point out that, in Sao Tome and Principe, which is a very small, 160,000 people live there, malaria is almost gone. But you go to the Democratic Republic of Congo with 69 million people, and malaria here in the heart of Africa is still a major killer. And this is a country that's going to be major problem in eradicating any disease because it's been so decimated by war and a lack of effective government that this is going to be a major challenge. So will we win? I think the consensus is that probably with what we have now, we're not going to quite make it. We need additional novel tools, especially in high transmission situations. We're currently relying on a very limited number of tools. So these artemisinin derivatives, the pyrethroids which we use in those nets, if those tools were lost to the emergence of widespread emergence of resistance, we would be in a bad place. And so the development of new tools remains a priority. And of course, we need world peace and development. So we need places like Democratic Republic of Congo to stop being at war, to have peaceful governments, and to actually have development so that there is enough money around in the system to actually pay for interventions that are needed. So I don't know, will we I don't think we'll eradicate malaria in my lifetime. Maybe in your lifetimes, you've got 30 years on me. Let's hope in your children's lifetimes at least, and maybe you can make a difference here if you actually specialise in this area. I've just got a little bit of a thing about the Global Fund here with Bono speaking. Let's see if we've got time. No, we have got time.
In fact, I called it a war chest. Quite a lot of people laughed it off, saying, "There he goes again, dreaming." And I love dreams. It always starts with a dream. Ask yourself, what do you need to live? Food? A home? A job? Your family? Love? And health? Without health, the others are not enough. It's one thing we all have in common. If we are in the same boat, then a hole at one end of the boat puts all of us at risk. Around the world, AIDS, tuberculosis, and malaria kill millions of people each year and handicap the development of entire nations. These diseases are not invincible, far from it, but to fight them, it takes commitment, the right strategies, money, and leadership.
The creation of the Global Fund was one of the kindest, most important things that happened to help improve people's lives. The treatment, whether it's for tuberculosis or AIDS or malaria, is saving lives, and that has a catalytic effect on allowing the community to take care of itself.
In 2002, the Global Fund to Fight AIDS, Tuberculosis, and Malaria was founded to bring massive amounts of new funding to the fight against these three diseases.
There's truly an era prior to the Global Fund and an era after the Global Fund. When it comes to AIDS, in 2001, 2002, there was barely anyone on treatment in the developing world. Today, it is over 4 million people who access antiretroviral treatment, the life-saving therapy for AIDS.
2/3 of all international funding to fight TB and malaria, and nearly a quarter of the money used to fight AIDS, is now being channeled through the Global Fund.
I think it's fantastic to see how money provided by donors turns into real help, real medicine, and save the life of real people.
Through the Global Fund to fight AIDS, tuberculosis, and malaria, over 3,500 lives are saved every day. That's 1.3 million people every year. We can win the fight against these diseases. It's just a matter of galvanizing the funding and getting the political will to achieve this.
Today, hundreds of thousands of health workers around the world are dedicating their work to saving lives with resources channeled through the Global Fund.
It's the countries that are in the driving seat. The countries decide on their programs, they decide on their budgets, they decide on how the money will be channeled. What we ask in return are the results.
The Global Fund is flexible. It doesn't make one-size-fits-all recommendations. The fund's focus on results has really helped drive progress towards the Millennium Development Goals.
While making sure that donor resources are being put to good use, the Global Fund is also strengthening ways in which partners can work together to fight diseases.
No one can fight an epidemic alone, nor the Ministry of Health or the public sector or the private sector or the civil society or the international organizations. When it comes to fighting an epidemic, everyone has to come together.
The Global Fund is run very professionally. It sets big goals, it measures itself, it's constantly improving, and the injection of resources, expertise from businesses could help the Global Fund be even more ambitious.
All of us can be proud of what we have established, what we have done. But more importantly, be conscious of what still needs to be done.
There can be no let-up in the fight against AIDS, tuberculosis, and malaria. If we ease up, these diseases will re-emerge. We either win this fight or we lose it. The success of the Global Fund is a test of global solidarity.
If we are to achieve the goal of eliminating transmission of the virus from mothers to children by 2015, there is still a lot of work that has to be done, but it is within our reach.
We can turn the tide on TB and ensuring that we've halted and begun to reverse the incidence of TB by providing access to treatment to those who need it. We also have the opportunity to end malaria deaths. Just like HIV/AIDS and TB, we have the tools needed to prevent and treat malaria. Death by mosquito bite, no. Not in the 21st century, we're not having that. These are very big and very bold.
Okay, I think I'm probably running out of time there, so I'll stop that now. That video's looking a little bit dated now, because with the economic downturn in the last couple of months, there's been some news that the Global Fund is actually under threat. I meant to actually look this morning to see what the latest news on that was, but it's amazing to see this wonderful global solidarity, but unfortunately, when there's a global recession on as well, it gets threatened, and so I'm not sure that the money is going to continue to flow. And in many ways, that we may be back to where we were 30 years ago, where you have this massive campaign and then suddenly it stalls. We hope not, but hope it does move forward. But anyway, I want to play that all the way through to the bit where Bono says that having death by a mosquito bite in the 21st century is not acceptable. I think that is probably the takeaway message there, is that we shouldn't be allowing this and tolerating this in the future.